All right, we're going to start with a basic example, just a linear equation over a linear equation, and go through all the steps of graphing, finding all of the characteristics, and then making a sign chart and putting it on the graph. So let's just start from the top, go through all our pieces, we'll put them on a graph, and then we'll find a sign chart. So the first thing we're going to find is the y-intercept. Now, remember, the y-intercept is graphically where our function crosses the y-axis. There's only one of those, and it means it's the ordered pair 0, y, right? It means x is 0. So to find the y-intercept, we actually just find g of 0. We plug 0 into our function. So this would be 2 times 0 minus 7 divided by 6 minus 0, which is going to be negative 7 over 6. Okay, so we know the ordered pair is 0, negative 7 over 6. We always have to do a ordered pair because it's a point on the graph. It's not a number, it's not a line, it's a point on our graph. So it's going to be 0, negative 7, 6. Okay. For factored form, it's already in factored form because there's no GCF that can be pulled out, and there's no quadratics or anything. It's just a linear over a linear. So 2x minus 7 over 6 minus x. Okay. Now, because when we factored it, well, there was nothing to factor, but in its factored form, nothing cancels out. There's no removable discontinuities. NA, you could say none. Both of those mean the same thing. There's not a hole in the graph. We don't have to find that ordered pair for it. Okay, so now if we think vertical asymptotes, remember that's where the function is undefined. And where is a rational function undefined? If we're dividing by 0. So to find vertical asymptotes, we set the denominator equal to 0. So we're going to set 6 minus x equal to 0, add x to both sides, and we will get that 6 equals x. So this vertical asymptote is that x equals 6. And again, here we need an equation because an asymptote is a line on our graph. Okay. For x-intercepts, we're going to set the numerator equal to 0. Okay, because an x-intercept is where the function, and there can be multiple, notice that s, it's where the function crosses the x-axis, which means its ordered pair is x, 0. So we need the function to be equal to 0. So we'll set g of x, the entire function, equal to 0. Sorry, I keep scrolling. 2x minus 7 all over 6 minus x. But notice every single time your first step is going to be to multiply both sides by the denominator, and it's always going to turn into 0 equals the numerator. So you can just remember that you set the numerator equal to 0 if you are able to memorize that. But if not, you can think of it, I know what an x-intercept is, so I can find it that way. So 7 equals 2x, divide both sides by 2, and we get that x equals 7 over 2. But remember, we don't want to write it like that because that is in the form of an equation. This is an ordered pair, so it's going to be 3.5 we'll go with, so that's easier to graph. 3.5, 0. Okay. For our horizontal asymptote, we look at the degree of the numerator versus the degree of the denominator for starters. And if I look at this function, this has a degree of 1 because the highest exponent, it's linear, is 1. And this also has a degree of 1, right? Its highest exponent is 1. And when the degrees are equal, that's when we take a ratio of the leading coefficients. Now remember, the leading coefficient is the number on the term with the highest degree. So we're going to be looking at this term and this term. And we have to be very careful here. The numerator, it's pretty easy. The leading coefficient, it's a 2. It's 2 times x. But down here, that's not 1. That's a negative 1. right? So our horizontal asymptote is going to be y equals -2. And again, we write it as an equation because it is an equation, it's a line. Okay, so now that we have all of these pieces, we're going to take these four things actually, these four things, and actually put them on the graph now before we make our sign chart. All right, so let's start with our intercepts. We had at 3.50, we had our x-intercept. It was 0, -7 divided by 6 for our y-intercept. That's like -1.66. That's going to be around there, maybe a little higher. Like that. And then we can put our asymptote. So our first asymptote, I guess I should say vertical. Our vertical asymptote was at x equals 6. So that's going to be right here. So I'm going to draw it in as a dashed line to show that it's, not our function, it's an asymptote. And then our horizontal asymptote was at y equals -2. Okay, so now we can make our sign chart because that's going to finish off everything we need to be able to graph. So first I'm going to type down the bullet points that we followed in class on Thursday for how to graph, just so I can remind you of them. So these are the 4 kind of bullet points we talked about in class on Thursday that, in addition to our sign chart, will help us graph it. So the first one is, it's a function. It has to pass the vertical line test. So in no way can we have a function that looks like that, because that's not a function. I can't call that a function because it doesn't pass the vertical line test. It's just not a function. So that's the first thing that helps us. And then also we have that it has to hit all of the points, right? So I can't just say, oh, my graph is going to look, like this, because it hasn't hit this point right here. So it having to hit all the points helps us get a good picture of it. It can't cross a vertical asymptote, and our function must follow it. So we know that our function is going to be some variation of one of these 4 things. Actually, 2 of the 4 is what it's going to look like. Okay, and then last but not least, as x approaches positive and negative infinity, the function must follow the horizontal asymptote. So you actually can, legally cross a horizontal asymptote, but only in kind of the middle. As it goes towards negative and positive infinity, our function has to follow the asymptote. So in addition to our sign chart, these 4 pieces of information will help us get a good look at this graph. So for the sign chart, we're going to start off giving it the little shell. Okay, keeping in mind our function is down here because we put our numerator, well, not our numerator and denominator. In this case, yes, but in other cases, it's, all the factors. So we put all of our factors because these the whole point is this, multiplied with this gives us our function. If we multiply this column together, we get our function. That's the whole point of that. Okay? And then along the bottom, again, we do this sign chart to see if the function is negative or positive. If the function is negative, that means that it's below the x-axis, right? If f of x is negative, the function is negative, it's below the x-axis. If the function is positive, it's above the x-axis. So having this information, knowing where on our graph the function is going to be, helps us get a good sketch of it. Well, to find out where it's positive and negative, we need to take into account the places where it could cross the x-axis, right? We know that this is not possible because we don't have an intercept right here. We can't, legally, whatever, graphically cross the x-axis there. The only places where we can change from positive to negative is at intercepts and asymptotes. So along the bottom, we're going to put the numbers in, number line order of any vertical asymptotes and x-intercepts, because it's just things that intersect the x-axis. Okay, so we'll call this negative infinity, this infinity. We've got both 3.5 and 5. So 3.5 goes first, and then 5. Okay, so just a reminder, along this side is going to be our factors. And then along the bottom is where we put our x-intercepts, if there are multiple, and our vertical asymptotes, again, if there are multiple. And then we just fill out this grid, and I'm going to draw in little grid lines, to determine if it's negative or positive on that interval. So we need to plug in a number within each interval. It doesn't matter what you use. Any number between negative infinity and 3.5 would give me the same value. Okay, so I'm just going to use 0. So I'm going to do f of 0. That's super easy. So then I just plug it in, right? And I don't care what the actual output is. I just want to know if it's positive or negative. So when I plug in 0, 2 times 0 is 0 minus 7, that's a negative number. 6 minus 0, that's a positive number. So a negative times a positive is a negative. So that means from negative infinity to positive 3.5, my function is negative or below the x-axis. Okay? From 3.5 to 5, the only really easy number to plug in would be 4. So we're going to plug in 4. 2 times 4 is 8. 8 minus 7 is a positive number. 6 minus 4 is also positive. A positive times a positive is positive. So that tells us that the function is positive above the x-axis from 3.5 to 5. Last but not least, 5 to infinity. I'm going to plug in 10. You could plug in anything between 5 and infinity. 2 times 10 is definitely bigger than 7, so that's going to be a positive. 6 minus 10 is going to be a negative. So our function is negative from 5 to infinity. Okay, and again, what does this tell us? So this is what we're really looking at. This tells us the intervals that the function is negative or positive. So I know that on, if we say, okay, we're going to cut it here from negative infinity to 3.5 and from 5 to infinity, my function is down here. My function is below the x-axis, okay? And then from 3.5 to 5, my function is up here. It's above the x-axis. So that means the only place my function is above the x-axis is in this little sliver. So I'm going to color that everywhere else. From negative infinity to 3.5, this whole thing, all the way here, is where my function is. And then from 5 to infinity, my function is there. Okay, so that is what the sign chart told me. The sign chart told me where my function can be. So, I can draw a function in here. I mean, this isn't like what the shape is going to be, but I could put that graph there, right? I could put a parabola facing down there, but I could not, shoot my function out like this because my sign chart doesn't tell me my function's there. So let's work from left to right following, these 4 rules in our sign chart and graph this thing. So again, from negative infinity to 3.5, I know I'm below the x-axis. But I also know I have to hit these 2 points here, right? And I know that I have to follow this asymptote, right? So I can't go like this. I cannot do that. While it does go through the 2 points, it doesn't follow the asymptote. It almost looks like it's following a vertical asymptote, but one doesn't exist there, okay? I can't go like this. Well, 1, I crossed over 3.5, but 2, this isn't a function because it doesn't pass the vertical line test. So the only thing I can do that makes sense following all my rules is to start at this point, go through this point, and follow my asymptote. Okay? So that's how using all of my things helped me graph the first interval. Now, this next interval from 3.5 to 5 is above the x-axis. So it has to be up here somewhere, right? Well, I can't go like this because that crosses the x-axis and starts going down again. But I know that I can't be over here until after 5, right? From 5 to infinity. So keeping in mind the few things I have to follow the vertical asymptote. It can't loop back on itself, anything crazy like that, right? I really only have one option here. I start at the point, because remember it has to hit all points, and then I just go up forever, making sure to be following the vertical asymptote. Okay? And then for the last interval, 5 to negative infinity, it's a little tricky because we don't have any points here, right? We weren't given any points to be like, oh, I know there's a point here. I have to connect it. We don't have anything. So we really just have to go off of the fact that, it has to follow these rules and it's down here, right? We know that our function can't just go like this and follow that way because it's a function. It would have an arrow on it. It would go on forever. It would eventually, just because you decided to stop drawing it doesn't mean that it's not continuing up forever. So we can't follow the horizontal asymptote that way. But what we can do, right, we know we need to stay down. We have to follow the vertical asymptote. So to follow our vertical asymptote, these are our two options. However, we can't be up here. Our function can't be up here, so that one's got to go. So I know that it's ending like this. I know that my function somehow, some way, ends up like this. Okay? And then I also know it has to follow the horizontal asymptote. Now, actually, we haven't talked too much about this, and I don't know if we even will, if we'll have time this semester. But you can indeed cross a horizontal asymptote. So we could actually have two different answers to this. We could go up and then come down and follow the horizontal asymptote, or we can just follow it this way. Again, I don't think we'll have time to get into all of that complicated stuff this semester, so you can just do either. Okay, it's not the biggest deal when we're getting a sketch. So keeping in mind that I have to follow both of these things, my curve's going to look something like this. Could it technically, look like that, be a little bit closer to the asymptotes? Sure. Could it technically, follow and be a little more shallow? Sure. But what I need to see is that it's in that area and following the asymptotes. So without that one, we don't want that one. This is a good enough sketch. Okay? Because again, we're just sketching this based on what we know. And now we're done. We have our function graphed. Okay? Notice from negative infinity to 3.5, we are below the x-axis. We are following the asymptotes, and we're hitting all of the points. From 3.5 to 5, we're above the asymptote. We hit our point, and above the x-axis, sorry. We hit our point, and we follow the asymptote. Then, from 5 to infinity, we are below the x-axis, but we're following both of our asymptotes in the only way we could. Okay, so that is done. Give you one last look at the clean graph. Then again, the sign chart. Next up, I'll be doing a little bit more complicated of one. So we're going to have 2 x-intercepts and 2 vertical asymptotes. So the sign chart will be a little bigger, but the idea is the same. Hopefully this helped you get a little bit better of an idea of what a sign chart was, and you'll see it in a few more examples.